So what is the zero of a polynomial? This is when y is equal to 0, so it's also known as our x-intercept or the roots or solutions. So let's find some zeros of a polynomial. When the function that we're given is given to us in standard form, we're going to set it equal to 0, and then we're going to factor. So here I have a GCF, so I'm going to factor out my GCF. I'm left with x squared, minus 4x, and then minus 4. We can keep factoring. So we get x minus 2, and then x minus 2. Once we have our factors, we take each factor, we set it equal to 0 and solve. So here, when we take the square root of x squared, we technically get a plus or minus 0. Now that's not a thing, so we just have one answer of 0, but technically it's 2. So when we solve both of these, we will also notice that we get 2 of the same answer. We have a special recognition for that. This is called the multiplicity of 2, meaning the answer of 0 shows up twice, and x is equal to also has a multiplicity of 2, meaning the answer x is equal to 2 shows up twice. And we'll talk about multiplicity in a second. So they both have a multiplicity of 2 because there are 2 of the same answers. When we're given our answer in non-standard form, we're going to isolate the whatever's being raised to the degree, and then we'll take the square root. So we're going to set it equal to 0. We're going to add that 1 to both sides. And then we're going to take the fourth root of both sides. And when we take that fourth root, because it's an even powered root, we have to introduce the plus minus sign. So we're going to have 1 is equal to x plus 2. So that answer is going to give me -1. And then we have -1 is equal to x plus 2. So we get x is equal to -3. Since both of these show up once, this has a multiplicity of 1. This has a multiplicity of 1. Now, sometimes you could have a multiplicity of 1 and then a multiplicity of 2. Each x value has its own independent multiplicities from the other answers or zeros of the polynomial. Multiplicity tells us what happens when we get to the x-axis. So if your multiplicity is even, 2, 4, 6, 8, that means that we're going to do a touch and turn on the x-axis. So we're not going to cross it, we're just going to touch and turn. When the multiplicity is odd, then we're going to cross over the x-axis. So what does that mean? I'm going to show you what that means with a sine line. So a sine line is going to determine where the graph is located in comparison to the x-axis. So this is when all the things that we have done come together. So the first thing that we're going to do is determine the end behavior. So here I have a positive leading coefficient and I have an odd degree. That means that the left-hand side is going to be down and the right-hand side is up. I'm going to then find my 0. So I'm going to set the polynomial equal to 0. I have 4 terms here. So because I have 4 terms, I'm going to use factoring by grouping. Because we're in standard form, I'm going to factor. So we have x squared and then x plus 1. Factor out a minus 4, x plus 1. We have x squared minus 4, which is a difference of perfect squares. So I'm actually going to factor it again. We're going to take each factor and set it equal to 0. So we get x is equal to -1. X is equal to -2. And x is equal to 2. We're going to take those and we're going to make a sine line. So we're going to take all of those pieces and put them together to make the sine line. So the first thing, the sine line is your x-axis, and then in next lesson, we will put it on a coordinate plane. So we're going to put all of these pieces together. We're just building up. So on our sine line, I have my answers, -2, -1, and 2. I know my end behavior. Whoops. Let me get my pen back. I know my end behavior says on the left-hand side I'm going down, and on the right-hand side I'm going up. So I'm going to put that on first. I know my multiplicity at -2 is odd, so I have to go through -2. I have to cross the x-axis. I'm also going to need to cross at -1, so I'm going to bring my line down and cross through -1. And I also, since I have a multiplicity of 1 at 2, I'm going to have to cross there as well. So this lets us know that under, and then we're over, and then under, and then over our x-axis. So we can tell where our function is above or below the x-axis. If all of the zeros here had a multiplicity of 1, let's say if we had a multiplicity of 2, we'll say the end behavior started down and up, just like that first example. And let's say at -2, we had a multiplicity of 1, so we would cross. But let's say that -1 had a multiplicity of 2. That means that we're going to come and touch and then turn at -1. So the multiplicity tells me if I'm going to cross the x-axis or if I'm just going to stay on one side of it. And that's sine line and day 2 of polynomials.